So there is nothing special about the stoichiometry that we are doing today. It's going to be exactly the same. It'll be a question that involves a reaction, as opposed to what we did earlier on in the week where we were just talking about one chemical, what's the concentration of, or perhaps we added some water and we diluted it. So this will involve a reaction. And whenever we have a stoichiometry problem, the first thing we do is we get a balanced chemical equation. Then we write the information underneath, and then we go and look for what we can look for. Just keep in mind, and I don't recall what my exact examples are, but just keep in mind all possible stoichiometry problems are fair game. So there could be a limiting reagent problem where we've got to find out what we have and what we need and use the smallest number, right? There could be a % yield on the end. All of that stuff is kind of part of the problem-solving questions that we can have. So all I'm going to do is a handful of examples here, and then I'll give you a sheet to work on, and that's it. I don't need to tell you what stoichiometry is. I don't need to define anything. We know our equation for getting moles if we have a solution, C equals N over V, and we answer the question. I typically like to do stoichiometry on the board because there's a little more room, but because I'm making the video, I am going to squeeze it onto that screen. And for those of you who like to watch the clock, I have 5 examples. And I forgot to remind everyone to put their phones away, but if you'd like to borrow a calculator, you could come and borrow one and leave me your phone as a rental. Thank you very much. Are you desperate for a charge, Gabriel? Are you desperate for a charge? You could plug it in right there if you want it to be. No? You're okay? Good. We got a table right there. Okay. A strip of copper, the excess reactant, Cu, was placed in 50 milliliters of 0.5 molar solution of silver nitrate, AgNO3, 1 and 1. That's going to be a single displacement reaction. Now, you don't need to do all the stuff we did yesterday. I have had in the past some students who think that everything that we learn needs to apply to everything. I am not doing a net ionic equation for this. I don't need to do that. I just need a balanced chemical equation so I can get a mole ratio and I can answer the question. It will say, write a total ionic equation and a net ionic equation in the question. It will not be a stoichiometry situation. What mass of silver? Ag. And we're going to have some copper nitrate. Remember, and again, this is like we're reviewing everything we've done up to this point. The copper starts as 0. So the question is, what charge of the copper will be formed? And we get that from the charge that's in bold, right? Remember, the charge that's in bold is the most common. 2 is in bold. CuNO3 2. All right. And to balance, I think I need 2 and 2. And I should pretend I'm recording all the time because Julia gives me answers all the time when she's recording. So I should just pretend. I'll just wear the microphone all the time. 50 milliliters. Remember, our first line was for grams or entities. but now it's also for volume, 50 milliliters. And we want to find the mass of silver. Now, just like before, arrow down, convert to moles with our equation. Now, I've already stated this to you. The C, the concentration, is like the molar mass. It's the thing that we need to turn volume into moles using C equals N over V. So I personally like to write C equals 0.50 molar right in the position where the arrow is, where I would put molar mass. Then I'm going to head over to here, get moles using the mole ratio. That's a terrible M. And then I'm going to move up to here. And what do I need to convert moles to grams? Refusing to answer. What do you got? I need a molar mass of the silver. So notice, we're not doing anything different. Now, if I want to get moles, I need to turn that volume into liters. If I leave it in milliliters, which sometimes we can, it simply means that I will get a unit of millimoles, because the milli would still be around. I think for this question, because we want to solve for grams, I might convert that to moles. Let's turn the milliliters into liters. If I didn't do that, I would actually end up with milligrams at the end, because the milli just follows along if we don't turn it into liters. Let's turn this one into liters. How many liters, how many liters is 50 milliliters? Tara, how many liters is 50 milliliters?
Is it 0.50?
No. 0.50 would be 500 milliliters. Would you like to try again? 0.05 liters. C equals N over V. We want to find N. Put it in whatever triangle you want it to be. N equals C times V. 0.50 molarity times 0.050, and we're going to get a small number of moles. That's okay. We can leave it as a decimal number, or you could turn it into scientific notation if your calculator's in scientific notation. I really don't care. I'm not calculating that. What do we have for a number? What do we got? Julia's not going to share anymore. What'd you get? 0.025? 0.025 moles. 0.025, yep, moles. That's good. At this point, I shouldn't have to do anything. We all did pretty good on that test. This is a 2 to 2. Should be able to get your moles to here. Silver. (107.9 grams per mole). I'm going to start from the original equation. What molar mass is equal to mass over moles. I want mass. I'm going to bring that moles up top, right? Because I want to get the mass. Molar mass times moles. And we get a mass. What do we got? What do we got for a number? What do you got? 2.7 grams. 2.7 grams. Do we like it? Do we like it? So this is 2 to 2, so that's the same as 1 to 1, 0.025. No need to show me that. The 2 to 2 shows me enough. 0.025. Oops, that should have been the moles. I've got it backwards. 107.9 grams per mole. 2.7 grams. So again, hopefully you're feeling comfortable with this, because all we're doing differently is if we're given a solution with a concentration, we use C equals N over V instead of the molar mass equation. That's it. Now there is one variation on it. I'm going to show you that variation next. There's one slight variation on this. I'll let you write the question down, and then we'll set it up. And I'll show you why this is a little different than the other stoichiometry that we've done up to this point. Same reaction. So this is the idea of this, was that you didn't have to worry too much about the balanced chemical equation. You can set it back up the same way. Okay, so again, we've got silver reacting with excess copper. I'm going to write the copper first just because, and that's with the silver nitrate. NO3, same reaction. It's going to produce some silver metal and some copper 2 nitrate. Whoops. Not a C. And O3 brackets 2. Again, we needed 2 and we needed 2. Again, if that question has been given to you, you're gonna follow the same instructions that I've always given you. Write the information underneath. In this case, we were using 100 milliliters of this. All right. And now I'm telling you that we obtained 1.80 grams. So this is a different type of question. And then it asks, what is the concentration of the silver nitrate solution? Now, before I even think about where I'm going or what I'm looking for, without putting the arrows on it, our map is going to do this in some way, right? We've got to get that information together. Where would I put the concentration in this map based on the question we just did moments ago? Where would I write the concentration number if I knew what it was? Yep. Right below the 100. Now notice, in this question, I am looking for the concentration. So this is a different type of problem. We've never had a problem where we're looking for the molar mass. We always just found the molar mass on the periodic table. But remember, concentration is a thing that we have to give you in the question, unless we're finding it, and it depends on the scientist that made it. Did they put 5 grams in 100 milliliters, or did they put 10 grams in 100 milliliters? Now, when I was first introducing you to the concentration questions, I said to you, when we ask for the concentration, write this down. And we always write it down anyway. What was it that I wanted you to write down? Essentially, it was the formula. C equals N over V. I'm going to put it over here because this is where I'm looking for it. C equals N over V. I'm actually going to put it right even in here where the question mark is. N and V. Well, notice, right here is the V. There it is. That would be the volume in which we're talking about. Where will I find the information about moles? Where will I find the information about moles of silver nitrate? Where does that appear on our map? Where does moles of silver nitrate appear on the map when I build the map? What's that? Right below it. Moles of silver nitrate. Moles goes there. I have the V. I probably have to turn that into liters. Not a problem. How can I determine this moles of silver nitrate? Somebody complete the map for me. Tell me where I go. What am I using? Yep. What am I doing? Correct. And I need, what do I need here to do that? I'm going to use the molar mass. Then I'm going to use the mole ratio. And then I am going to stop at this position here. Stop. And I now then have moles, and I can put that and solve it. So when it asks for concentration, I will be given the volume. I will use stoichiometry to get the moles, and then I'll put it in C equals N over V. At this point, you should be able to proceed, because grams to moles is something we know how to do. We've done that before. Mole ratio, again, it's a 2 to 2, so that's nice and easy. And then we'll just stick it into C equals N over V. As easy as that. You can go ahead of me. You should know AG from the other question. This is, again, molar mass is equal to grams over moles. And in this case, I need to get N. So I need to be careful when I rearrange that one. It's different than the last time I did it. Once I have the N, I can head back this way with a 2 to 2. And then I can put everything into C equals N over V. The V, because it's going to be in moles, has to be in liters, 0.100 liters. If I had millimoles, I guess the milliliters would work. Millimoles and milliliters would get us moles per liter. We'll do an example like that a little later. 107.9, was it? Can't remember. Grams per mole. I'll take moles, if you got it. Kaylin, have you got moles? 0.016 moles. Do you like it? Do you like it? No. To 7. 17 moles. 0.17, 2 to 2, 0.017, 0.017 divided by 0.1. That's the same as multiplying by 10, 0.17 moles per liter. Is the C? All right. All right. I said I had 5 examples. I've got no problem taking one away. Let's see if there's one that I can get rid of. Don't write this down right away when I advance to the next slide. Let's see what that one is. That's just straightforward. That's another concentration one. We just did it. I like that one, though. Maybe we'll do that one last. Let's do this one. Let's do this one. And then we'll go up and do number 4. Don't worry about the numbering. Let's do this one first, then we'll go back up and do the number 4. And then I'll only do 4 examples. So here I've got two solutions reacting, and I've got all the information for both. So that might get you thinking about what type of question this is. This one's a little evil in that I'm expecting you to know the type of reaction and then how to determine the precipitate. So if I've got NaOH and it is reacting with aluminum nitrate, Al, NO3 brackets 3, 3 and 1. So this is a double displacement. Again, I do not need the net ionic equation. I don't need it broken into ions. I just need a mole ratio out of this so that we can solve it. What are the products going to be when they displace? What are the products of the double displacement going to be? Yeah, what do you think? Yeah. We've got Na, NO3, 1 and 1, right? And what's the formula for the aluminum hydroxide going to be when we look at the charge on the aluminum and the charge on the hydroxide? We cross it over. I need one more thing here. I need a 3 on the hydroxide, right? To balance it, I'm going to need 3 of these and 3 of these. Which one is the precipitate? Which one is the solid that's formed in that reaction? So notice, now you need your chart on solubilities to determine which of those two things will be the solid. Are you ready to share? No? Still not ready? Okay, that's fine. It's all right. When you're ready, you can let me know. Sure, what do you got? The aluminum hydroxide is the solid. Excellent. So this is what we're looking for. Question mark grams. I have 15. 15 milliliters at a concentration of 0.75 moles per liter. And I have 15 milliliters at a concentration of 0.85 moles per liter. And what do I have to determine first? It's more exciting than that, Riley. This is exciting. What do I have to determine first before I can solve the question? I have to determine the moles, but what do we call this type of question where I give you the information about both of the reactants? Yep. It's a limiting reactant problem. So I need to figure out the moles of these, and I need to convert it to find the mole that I need, and I need to find the moles that I have. And again, I'm going to need the mole ratio. In this case, it's 3 to 1. I'm going to need lots of C equals N over V to find the moles. I'm going to have to do it for both, and then put my numbers in. I'm doing it the same as I would if it was masses. The only difference, I'm using C equals N over V instead of the molar mass equation. N equals C times V. Again, if you don't turn it into liters, we're going to have millimoles. which I guess is okay. You could compare millimoles. Just in the end, I would get milligrams. I guess that's okay. Milligrams is a proper unit. We'll use the milli later on, and I'll explain where sometimes it's going to be useful. I would put for this one 0.75. There's the C, and the V 0.015 liters. So I'm doing the NaOH there. And I'll take that N when you got it. Who wants to share? Who's got it? What do you got? What do you got there? You got an N yet? 0.01125. 0.01125 moles. Lots of digits there, but that's okay. We can keep them. 0.01125. What am I going to do to bring that down to the 3-to-1 ratio? Divide by 3, right? Again, for those who need to see it, it would be 0.01125 over 3 equals x over 1. If we're getting good at the mole ratio, I don't need to see that. What is that number divided by 3? Didn't you write it down? Oh, we haven't done it yet. .03. That's dividing by 3? No, that looks like that's multiplying by 3. 0.003? What do we got? 0.00, right? 375. Now I've got to determine how many moles of the aluminum nitrate I have. Again, N equals C times V. 0.15. Sorry, that I should put the 0.85. That's the first one. 0.85. The V is 0.015. So I'm now doing this calculation down here to get my other number to see what we have. What number do we get there? What do you got for moles? 0.01125. That's a 0.85, so it should be a little different. You have the one that goes down. 127. 0.01275 moles. So what you got? 0.01275. Which one am I going to use? The small one. Yeah, that's correct. I'm going to use the small one. The small one right there. That's the little guy. Notice this question doesn't ask, what is the limiting reagent? Just a reminder, the limiting reagent, we go back to the thing that produced that smaller number. Sodium hydroxide is going to run out. So technically speaking, the sodium hydroxide is the limiting reagent. It's not part of the question, but it's there. And now I'm going to take that and go over to there. It looks like a 1-to-1. And I'm going to head up to there with a molar mass. And I have it. 0.00375 moles. One times 3, 16 times 3. I don't use aluminum very much. 27. 27. $78. And molar mass equals mass over moles. That's just, I always go back to the main one. I want mass, so mass is equal to molar mass times moles. However you're doing that, maybe you got it memorized at this point. That's great. 78 is the molar mass. The moles 0.00375. How much of this stuff is formed? What do you got there, Kevin?
0.2925.
That's okay, 2925. 2 digits, it looks like, right, in our concentration, that formula. So 2 digits, 0.29 grams, will be expected there. Okay? Again, we all know how to do that, and it's good. Look at that. Rhea's like yawning. It's because she knows exactly how to do these problems, because we've done stoichiometry already, and that's fine. That's okay. That's why I don't want to do 5. I do want to do one more. Okay, now I'm going to go back up to 4. Does everybody have all the information they want off of that? Yes? Yes? All right. Oops. No. Backwards. Number 4 right there. So this is a little bit of a preview to what we will be doing in the next part of the unit on acids and bases. This is, again, is a neutralization reaction. And we've already done one like this where it says determine the concentration, which means we're going to be looking for a C equals N over V. This is the type of reaction that we're actually going to do in the laboratory. And it's a very useful and very powerful way of determining unknown concentrations. This allows us to take a solution that we know the concentration of. In this case, it's the potassium hydroxide, 0.150 molar. And through a neutralization, we're going to use that to determine the concentration of an unknown acid. Again, I always give you the easy one, the base, and that's because I need you to think once in a while on certain acids. Acid names and formulas are quite important in the chemistry world. And sulfuric acid is one we use quite a bit. Anybody remember what the formula for sulfuric acid is? We used it the other day. Again, it is based on the sulfate. Julia, would you like to tell me what it is?
Not
It
really.
is H2SO4. Through great repetition, we're going to get that one figured out. This is a neutralization reaction. We did a net ionic equation with this yesterday, but we're not looking for that. The K is going to go with the sulfate, K2SO4, hopefully you're ahead of me. And then the H is going to go with the OH to make water. And like I said to you when we started balancing, balance the waters last. Coefficients, what do I need to put where? 2 KOH and 2 waters. All right. A 10 milliliter sample of sulfuric acid reacts completely with 15.9 milliliters of the KOH. We know the concentration of the KOH. And we want to find the concentration of the acid. And this is, like I said, a very useful and typical type of an experiment, of a laboratory technique. It's called a titration. We will do it right before the Christmas break. Now, in this case, I'm going to say, let's leave the millis. I'm going to show you how this can be useful. We do not always have to convert to moles. We could convert to millimoles. Again, I'm going to go down to here, and I'm going to go across to here, and I'm going to figure out the millimoles over here, and I'm going to stop over here, and I'm going to take the V from here and put it in there, and I'm going to take the N from there, and I'm going to put it in there. It's the same calculation we just did moments ago. If we leave it as milli, again, C equals N over V, and I want to get N, because I need the millimoles. Moles or millimoles, still N. N equals C times V. The C is 0.150, and the V is 15.9. We're going to keep milliliters. And because we kept milliliters, we will have millimoles. And sometimes it's nicer to work with those numbers. What are we getting for the millimoles? How many millimoles? So those last examples, we had like really tiny decimal numbers, and they were a pain to write out all those extra zeros. In millimoles, you don't have that. Carol, what do you got? 2.39. 2.39 millimoles, 2.39. We have a 2-to-1 ratio. You'll notice that number that's in your calculator, we just keep manipulating it. Divide by 2. I can't do that in my head. 1.15. Divide the 9 in half. 1.19, 1.18. What is it? 1.19. 1.19 millimoles. Now, when we put it in to find the C, whoops, C equals N over V, it says right there, C equals, I'm going to put in the N, 1.19 millimoles divided by 10 milliliters. And if we do some analysis like you did in algebra years ago, or maybe not, maybe like grade 9, those millis can cancel out. That means when we divide 1.19 divided by 10, we still get moles per liter. It's the same unit. That's why sometimes it's useful to do that. You don't have to. If you don't like the idea of millimoles, you can divide those volumes by 1,000 and work with those tiny numbers. Everybody will end at the same answer with this. That divided by 10 will move the decimal place over once to the left. 0.119 moles per liter. Looks like 3 decimals. 3 decimals, 3 decimals, or sorry, 3 digits. 3 digits. I like that number right there. Okay. Again, I'm hoping that you're feeling calm in that we really haven't done anything new, except now when we're given volumes and concentrations, we're using a different equation to get moles. Yep. Yep. Oh, it will begin, will it?
Yeah, I'll make laugh.
There's all kinds of, I knew that this was going to happen. We're feeling antsy here today. Let me think about it for a moment. In other words, I'm going to show you what the homework is in that, and once I get things rolling and set, I will consider your request. Okay. In terms of homework, there you can write down the textbook work. I am going to post the questions on the board, on the smart board, because I didn't print it out this time, and I still want you to ideally have your phones away. The answers should be on the sheet. I will also post the review today, like right now. On my next slide, there are the review questions. Is anybody interested in writing that stuff down? Okay. I will put it up in a moment. The answers, you don't have to write the answers to the handout down, because I'm pretty sure I've got them on the handout. If not, I'll put them there. Does everybody have that information off that slide? All right, so you can write down the review.